Hello friends, thank you for watching this video. I am Mohamad and today we will be exploring what is Azure Service Bus. If you like this video, please like, share and subscribe. It will really help the channel. So, what are we going to be covering today? First, we're going to be covering what is Azure Service Bus, some of the terminology that we will be using, application structure, old versus new, types of Azure Service Bus, some protocols that Azure Service Bus utilize, and Azure Service Bus features. So first of all, what is an Azure Service Bus? In essence, Azure Service Bus is a way to send the messages from point A to point B, which means that if I'm going to put an information somewhere and someone or somewhere on some service is going to be able to pick it up and utilize this information. So as we can see here, this computer is trying to send some information somewhere. It's preparing some kind of a message, then it's putting it inside this let's say we can say it's like a drawer, and then this server is pulling out this information one letter at a time. Azure Service Bus leverage the idea of async process in the messages queue, which is very doable, which means that it's very hard for us to lose any of the messages that exist within our drawer right here. So, what is a message and what is a queue? A message is a JSON object which contains all of the information that we want to send from point A to point B. So basically, inside every message, there's like a JSON file, a JSON object which represents all of the information that we are sending. What is a queue? A queue is a list of items that is sorted to be retrieval and in a definite order. And usually it's an order of insertion. So it's a FIFO order, first in, first out. So a queue, let's say for example, it's our drawer here, and all of the information that we put in, this information goes out based on the ordering that they have been inserted in. So for example, if this is the first letter that I have put in, it will be the first one that's gonna go out, and this is the last letter that I have put in, it will be the last one that it will go out. Of course, there's certain exceptions to this that we will be discussing later within this video. So now we're gonna be exploring what's the difference between a traditional application and a new way of application. So let's take a look at this example of a food ordering system. So this is the user who wants to order some food. They go onto their mobile application, they decide what they want to eat, and the mobile application will send the request to the API. In an old monolithic application, the API will have to do all of these in a single process in order for the food to be received and delivered. So it has to check for payments, then it has to check for the address if it's valid, then it has to check for the restaurant if it's able to take that order. If the restaurant accepts, it needs to process the payment, and then it needs to send confirmation for the user and the restaurant, and then it needs to send an email, and then it needs to notify the rider to go to the restaurant and update the food, and then it needs to send the update to the user. So basically it's a very step-by-step process that in case, let's say, the payment processment has failed, even though if the user has the money in their account, the entire process will fail and the user will get that the request has failed and they need to do all of this all over again. And basically there's a lot of reliance on previous services. So it's like if 1 pass, 2 will happen, 3 will happen, 4 will happen. So it's basically a very big monolithic application. And it's not really very good user experience, as well as it has some pros and cons. So the main pros to have somewhere similar to this is it's very easy to host, and there is a single point of processing. So basically, once you upload this here, all of your code in a single repository, for example, and a single project, and everything will be running from there. But again, this has a lot of cons as well. So there's a single point of failure. So let's say if the payment process had failed, the entire application had failed or crashed, it's very hard to scale. So if, let's say I want to just scale the rider notification system because I have a lot of riders who's going to be picking up the food, this is going to be very costly if I'm going to upgrade all of these services just for one service. It's a very bad user experience. In case something happened, the user have to do all of this all over again, and it's very difficult to maintain. So let's say my payment provider updated their API, and I need to update my API so I can use the payment provider's services, there's a chance that this application have to go down and like have some downtime until I upload the new version of the application with all of the changes that is required. So although it has some pros, but it has a lot of cons. And this is the traditional way. For this reason, there was a new way that has been introduced. So what is a service-based application? As we can see here, the application divides the works that needs to be done on different services. So previously we had one application was doing all of the checking of the system, checking of the address, checking of the restaurant, which is doing it in a specific order. But here, once the user wants to order the food, he will use the mobile application, which will gonna be connecting to the API. The API is gonna do initial check, which is the main check to see if the user has enough credit in their account in order for them to be processed. If the if the payment check is successful, then all of those services gonna get initiated, and the user's gonna get an initial message telling them that their order is gonna start to be processed. So first of all, we have gave the user a very good user experience. Second of all, after we did the initial check, we can see that we have divided the work into different services, and all of these services are working asynchronously at the same time in order to have a way better result and a much more reliable way. Second, if for example I want to update the email queue here, I don't really need to take all of the application down. So for example, once I check for the payment, there's gonna be a message in this queue coming to the there's gonna be a message in the email queue. This is gonna go to the email service provider. So if this service is gonna be down, the messages are all gonna stay in the queue until someone is gonna be able to pick them up. So let's say I got 6 orders while I'm updating, or 7 orders while I'm updating my service. All of these messages gonna stay in the queue until this service is up again and is able to take the emails from the queue. So until the service is up again and it's able to take all of the emails from the queue. So basically, it's a more sustainable way to develop application. It remove a lot of the downtime that we could face. As well, it allow us to divide and conquer, which means like we can divide all of these different services into different tasks, into different services, and we can handle them one by one instead of having one big monolithic application that's gonna be handling all of those. So what is the pros and cons for this? The main pro that we can see is basically dividing those services. It's way more easier to scale. So let's say I have a lot of processing power when it comes to rider management. So I can directly only scale this one here instead of upscaling all of these applications. And once that goes down, I can just scale it back down. Second, it's very easy to maintain. So let's say I want to update my payment provider here or somewhere. I don't have to like take down the entire application as we said before. All I need to do is the queue is gonna contain all of the messages that are gonna come to this payment provider, and then once I updated, it will gonna start picking up the messages all over again. So there's not gonna be any downtime. It's a better user experience because the user will get notified upon what every service is finished. It's less error prone because if one service fails, it's not gonna take the entire application with it. But there's also some complexity and some cons when it comes to these types of implementation. The first thing is it's gonna be a bit complicated to host in order to make all of these services running all at the same time and have all of the right access in order for them to communicate with each other. And as you can see, this can be a bit much if we're gonna break down every single service to have its own unique service. So for this reason, it's always better to think of what services needs to be stick together and what is the service that makes sense to be separated. So, what are the types that Azure Service Bus provide? So basically, we have 2 types. We have something called the queue and we have something called the topics. And the queue is the easiest one to to understand, and then we're gonna go to the topics. So basically a queue is like a FIFO approach. So first in, first out. So the first letter that's gonna come into this drawer, for example, is the one that's gonna go out. And basically there's only one certain type of application that's gonna be able to understand the messages here. So let's say we have 2-3 servers here. Only one of them will be able to check with this queue and get the information out. The other two will not be able to understand what's going on. We can have as well, if this application, for example, of type 1, we can have 2-3 of them, and those 3 are trying to read at the same time from the information from the queue here. The queue will lose information, because if one of them goes out for a different service, it's lost because it has been processed and it has not been processed. So whenever another type of service tries to pick it up, they will not be able to, because the message has been removed. So this is why in a queue it's always to have a better one service which is reading it, and it's again, it's a point-to-point model. So we're going from point 1 to point 2, and there's nothing in between, but that's gonna be processing this information. So as we can see, this is a very simple approach of a Azure Service Bus. Let's do a quick summary. So basically we just have one queue, or let's say one drawer. All of this information are going in, and the service is picking up one at a time, and is basically taking it on first in, first out. So the FIFO model. Second, what is a topic? So topic will have subscription. So when we said before, let's just go back to it. We said here there's only gonna be one service which is gonna be able to read from the queue. Topic is different. Topic, we have 3, 4, 5 services or 6 services. No matter what, they will be able to read from this queue, and they will be able to subscribe to it. So they're gonna have a publish subscribe model. So for example, I have service 1 here, which is gonna be handling, for example, the payments. Service 2 is gonna be handling email services. Service 3 is gonna be handling profile management, for example. So whenever a message comes into the queue, no matter what is the services, if they are subscribed to this queue, they will be able to receive the message. So the message is gonna be copied to the 1, 2, 3. It's not gonna just be lost if it goes to service 1, and service 2, 3, 4 will not be able to know about it. No. So if the message go to service 1, a copy of it will go to service 2, a copy of it will go to service 3, a copy of it will go to service 4. So in this way, we are copying the messages and we are sharing it across different services, which is subscribed to them. So what does publish subscribe models mean? So publish subscribe means that if I'm a service and I want to get an information from this queue, once it's published to this queue, I want to subscribe to it. So when I subscribe to a service, when I subscribe to a queue, whenever there's a new message which is published, I'm gonna get a copy of it. The next thing here that I want to cover as well, let's say server 3 is handling the payment, for example, and it doesn't really need to know every single message that's gonna come unless it meets certain conditions, like it has payment flag, or it has, for example, refund policy, or any of these. So but other than these 2 conditions, it doesn't really need to know about all of these messages that in the queue at this moment. So for this reason, this contains filtering. So service 3 can implement filtering, and it can only take the message that meets its filtering criteria. So what are protocols? What are the protocols that queues and topics use? Azure Service Bus support different protocols, and the main one that is used across almost, I want to say 99% of all of the queues and topics is called an AMQP, which is an advanced messaging queue protocol. And this one is basically used across all of the queues, topic, all of the services. There's certain other type of protocols which are implemented. For example, the Java messaging service, which is only available for Premium Bus and has some kind of different prototypes which I've never worked with. And there's also an HTTP protocol, which is basically used in order for us to avoid certain ports or certain networking restriction. We can use as well. I haven't worked with this because it's very rare to use these two. The main one, which is like mainly used across different organization and different types of Azure Service Bus, is going to be the AMQP, which is the Advanced Messaging Queue Protocol. So now we're going to be discussing some of the features that comes with Azure Service Bus. The first one is dead lettering. So what is dead lettering? Dead lettering means if we publish something to the queue and the process will fail to process that message, it will go back into a separate queue called dead letter queue. So let's see here. A computer here sent a message to the queue. Everything is going normally until the service wants to pick it up. So once the service pick it up, the service fails to process it. So it means, for example, that the data within that object is wrong, or the service was down, or there is any the filtering criteria, for example, for it didn't pick it up correctly, or any random reason why this service has failed to pick it up. So this message here, it will not just get destroyed and deleted forever. What happens? So this message is gonna move into another queue, which is called the dead letter queue. And within the dead letter queue, it's gonna allow us to take a look at this message in specific. We can see what's going wrong with it. We can see the contact of it, so we can debug it. And basically, it will allow us to see if this service is back up, we can move it again to the normal queue and process it again. Or we can resend it, I mean. This is dead lettering. The second feature is subscription, which is we have already covered before when it comes to reading messages from a pub-sub approach. So for example, if we said this queue is the restaurant queue, and these two services only care, this service only care if there is payment, and this service only care if there is like restaurant information, and the rest we don't really care about. So they add filters to those services, and they only pick up messages based on those filtering. The next feature is message sessions. What is message sessions? If we want to group certain messages together and make them processed at the same time, it's called a message sessions. So for example, we have here two messages that we want the service to pick them at the same time and process them at the same time. Azure Service Bus provide us with this feature. We can say like we put them together in a single session, and this way when a service picks it up, it checks, oh okay, these two messages are part of the same sessions, so I need to pick them up both at the same time. So it's a very good way to process them if we have, for example, concurrent order that needs to be happening simultaneously. This functionality is very helpful for that. Scheduling. So what is scheduling when it comes to Azure Service Bus? So in essence, scheduling means that the message will go into the queue, but it will not be able to be picked up by the service until it's right time. So let's say I wanna send an email to all of my subscribers at 11 a.m. in the morning, telling them that there's a new video, for example, that got released. So what I can do is I can send a message to the queue, give it a time of when it's gonna be processed, and only at 11 a.m. the service will be able to see, okay, there's a message that's gonna be processed at 11 a.m. They're gonna be able to pick it up and be able to use it at that time. Other than that, it will just be ignored and stay in the queue until that time is gonna arrive. It will not go to the dead letter queue because it didn't fail. It's just waiting for its right time and the right time slot to be processed. The other feature that we want to discuss is duplicate message detection. So Azure Service Bus queues is smart enough to detect if there's a message which is a duplicate. So as we can see here, we have the first message, then we have two messages which are exact duplicates, and we have the third message. So Azure Service Bus is gonna be able to identify that there is a exact duplicate message between the two, and basically they're gonna be ignoring one and they're gonna be sending it to the dead letter queue because it's gonna be a duplicate. So this is some of the built-in features that allow us to prevent some errors and have a better user experience. What is a time to live? if we add a certain deadline to a message, so let's say we add like you have 6 hours to be processed. If you don't get processed within the next 6 hours, you will be ignored and you're gonna be go to the dead letter queue. So if we add, for example, this deadline to a message, and let's say those 6 hours has passed, the service here is gonna say, okay, you have been published for more than 6 hours and you only have time to live for 6 hours, so I'm not gonna be processing you, so you're gonna go to the dead letter queue. So this way it's valid, for example, in this scenarios, it's valid, for example, if let's say we have like a student who needs to submit their homework within 6 hours. So let's say it's if they have a time window, if that homework has been submitted within the 6 hours here, this service is still up and running and they will be able to pick it up, this homework. If it passed the 6 hour that's allowed to live, the service is going to completely ignore it and reject it. I hope this video was beneficial and gave you a good introduction about Azure Service Bus. It's a service that Azure provides which has a lot of potential, and you can utilize it in so many different ways in order to make your application way more sustainable, much more reliant, and way more scalable. Thank you for watching, and please comment if you have any questions or you have any inquiries, and subscribe to the channel. It will really help this channel to grow. And please like this video. Have a great day.